Hi, in this video, we are going to solve the 11th numerical, which is also the last numerical for the exercise in the chapter Motion in a Plane. But before we get into the question, there's one aspect of question which I want you guys to understand. So in this particular question, we occur on the word range at two instances. So one is in the context of velocity and one is over here. Okay, now both this context, the meaning of range is different. So when we are talking in context of our velocity, range means the upper limit and lower limit. So it's like this is the season of monsoon. So if we go to a shopkeeper and if we say ki, okay bhaiya, show me an umbrella between the range of 500 to 750. In this context, range represents the values which can take place between a lower limit and upper limit. But in the second context, range means the horizontal distance for projectile. So projectile में range का मतलब होता है horizontal distance traveled by my projectile. So these are the two differences between the meaning of range that one need to be clear of before solving this question. Okay, now let's quickly move on to our question. It's a easy question. ओके तो क्वेश्चन में क्या बता रहे हैं कि हम एक पार्टिकल को बार बार लॉन्च करेंगे एट अ फिक्स्ड एंगल ऑफ प्रोजेक्शन एंड दिस एंगल ऑफ प्रोजेक्शन इज सेट टू बी 30 डिग्रीज. सो लेट्स से हमने पार्टिकल लिया और उसको एक बार लॉन्च किया विद सम वेलोसिटी एंड देन हमने उस एक और बार सेम एंगल पर पार्टिकल को बट अभी कुछ हायर वेलोसिटी पे लॉन्च किया. सो दे क्वेश्चन इज आस्किंग अस कि गिव मी अ रेंज ऑफ वेलोसिटीज सच दैट मेरा जो ये हॉरिजॉन्टल डिस्टेंस है दैट कम्स बिटवीन 40 मीटर्स एंड 50 मीटर्स. सो इन दो डिस्टेंसेस के बीच में ही मेरा पार्टिकल जो है वो जाकर यहाँ पर इम्पैक्ट करेगा. सो इन क्वेश्चन दे आर आस्किंग अस दिस रेंज ऑफ वेलोसिटीज विथ विच वी कैन लॉन्च आवर पार्टिकल टू acquire this desired range. Okay, so that's it. So सबसे पहले let's start with our given data. So सबसे पहली quantity जो हमें दी गई है that is angle of projection theta which is 30 degree. Okay, and this 30 degrees. Then the second quantities which we have been given is the lower limit and the upper limit of this horizontal distance, that is this range. So I am going to represent range RL as the lower limit of range which is 40 meters, and then we also have the upper limit which is RU which is 50 meters. Okay, and then हमें क्या बताया गया है, हमें बताया गया है कि we can assume G as 10 meters per second square. So this is the approximate value of G which we can assume, and based on this we have to find one quantity, that is the range of initial velocities. Okay, U ये हमें पूछा गया है. This is unknown to us. So the only formula which makes sense जिससे हम initial velocity ढूंढ सकते हैं using range, that is horizontal, is the formula for range of projectile, that is R is equal to U square sine 2 theta by G. ये formula हम सब लोग ने पढ़ा है. So this is what we are going to use to solve it. So let's quickly solve our sum. So सबसे पहले हमारा जो भी desired range achieve होगा because of some velocity, that has to be greater than or equal to our lower limit, that has to be greater than or equal to lower limit of our range, that is RL, and that has to be less than or equal to the upper limit of our required range, that is RU. That is these two quantities. Now if we substitute the values in this, so this becomes 40 and this becomes 50, and I can represent a range in terms of its formula, that is U square sine 2 theta by G. Now if we focus on this equation, I can say that if we solve this equation, I can get the lower limit of my U, that is the required initial velocity, on this particular end, and I can get the upper limit for this initial velocity on this end. So let's solve this equation. So what I'll do now, I'll isolate my u term and I'll shift all the terms on the either side. So if I have to shift, I'll get 40 into g divided by sine 2 theta should be less than or equal to my u square. And over here also, so this particular setup is like we are solving our equations in two particular half, one across this section and then second across this section. So whatever values we multiply or divide, we have to do it on both the sides. So over here we have the term 50 into g divided by sine 2 theta. Okay, if I take square root on all sides, I get root of 40g divided by sine 2 theta should be less than equal to u should be less than equal to root of 50g sine 2 theta. Now let us quickly substitute all the values of theta and g in this particular equation. So we get our equation to be root of 40 into 10, which is the value of g approximate, and sine of 60. Since theta is 30, 2 theta becomes 60, should be less than equal to. And similarly, we have 50 into 10 upon sine of 60. Now the value of sine of 60 is root 3 by 2. And if we do all this calculation, we will have two particular terms. We will have something 800 by root 3 on this particular corner of this equation, and on the other corner we'll have 1000 by root 3. And if you were to solve this further, we would get the lower limit of u as 21.49 meters per second, and the upper limit of the u should be 24.03 meters per second. And this is what was required by us. So this was what we were supposed to calculate, which is the lower limit and the upper limit of the velocities. So as long as my particle is launched between these two velocities, I should get the desired range. That is, my particle should travel 40 or between 40 to 50 meters horizontally. Okay, so that's it. So for your screenshots, these are your screenshot for the given data and the visualization part. And for the solution, take the screenshots over here. This is the first half of the solution, and then you get the final half of the solution. With this, I hope this helped you. Thank you.